Imagine storing all the information in the New York Public Library on a device smaller than a fingernail. Or making materials that are stronger than diamonds but weigh less than a feather. Or developing catalysts that make the combustion reaction inside your car's engine so efficient that your vehicle gets many more miles to the gallon. These are some of the possibilities of nanoscience, the study and structuring of materials at the level of a few billionths of a meter, which is about 10,000 times smaller than the thickness of a human hair. So that researchers can explore these possibilities and, in the process, discover nanoscale structured solutions to U.S. energy challenges, Brookhaven National Laboratory recently opened its newest scientific research facility, the Center for Functional Nanomaterials. A state-of-the-art building with specialized laboratories and the most advanced instruments, Brookhaven's Nanocenter is one of 5 centers built by the U.S. Department of Energy. Brookhaven Center is the only Energy Department nanoscience facility in the Northeast United States. The Center for Functional Nanomaterials will be home to about 60 resident researchers and support staff, and the research destination for some 300 visiting scientists each year from universities, industry, and other labs primarily in New York and other states in the Northeast. Because materials structured on the nanoscale can have different chemical and physical properties than do conventional materials, the goal of nanoscience research is to develop new and improved materials, ones that are stronger, lighter, more reactive, or more energy efficient than present-day materials. Resident and guest scientists at the Center for Functional Nanomaterials are working in 3 research areas: nanocatalysts, biological and soft nanomaterials, and electronic nanomaterials. Using the CFN's many unique facilities, these world-class scientists are just beginning to explore the new and exciting world of nanoscience.
The Nanocenter is really in its initial phases right now. My colleagues with laboratories are working very hard to get the new equipment put into the laboratories and test the new equipment and start doing experiments. We're also in the process of identifying promising young scientists to bring in as new staff members or as postdoctoral researchers. So we're really at the building phase right now. Fundamentally, nanoscience has got to be a team sport. We need a lot of different talents to really understand these exciting but complicated new materials.
So in the CFN we have dual roles as staff scientists. One of our roles is to do internal science, push the science forward on our own, but a very important mainstay of our activities in the Center for Functional Nanomaterials is working with external users. Our facilities are quite unique. They include machines that one might not find in a university lab, but they in particular combine machines that are very powerful on their own, but even more powerful when combined under the same roof. So a user might find that he uses a machine that he applied for, but then has the opportunity to come and use a different machine that may complement what he has already learned with the first technique and make the combination of the two much more powerful than anticipated.
What is it we're talking about when we talk about nanoscience? In a fundamental sense, what we're really talking about is the properties of materials when they are fabricated to be of a scale that's of the order of maybe 10 or 100 atoms in extent in one dimension or more. Examples of these sorts of things would be something like a small metal nanoparticle that might have a few hundred atoms in it. Another example is semiconducting materials. These are the kinds of materials that appear in electronic circuits in your computer, but when they're at the very small scale, again, a few hundred to a few thousand atoms, they have new properties. The idea that nanoscience can have an important impact on the country's future energy supplies is really a key motivating factor in our new center. The Department of Energy as a whole has taken it upon itself to carry a key role in trying to secure the country's energy future. And we believe that fundamental research is going to play a key role in that process. We have to be thinking out 10 or 20 years from now and recognize that to really achieve a big change in the supply of energy for every citizen in this country, we need fundamental breakthroughs. We need to be able to gather energy from the sunlight that's all around us in a profoundly more efficient way than we're capable of right now. Nanoscience offers a lot of promise in this regard.
Here at the CFN, we believe that exploring the ultra-small will bring very large discoveries that could revolutionize the way we live.